Hello and welcome to our new video where we discuss about continuous random variable. In my some previous video you saw already normal variable, normal distribution, then standard normal distributions. Now continuous random variable. We discuss about the continuous random variable. Before I start continuous random variable, we have to know that which type of variables are present. So there are two types of variable, as you know. One is discrete, second one is random variable. So what are which type of variables we call discrete variable? Discrete variable which are set of data which are coming always in the whole number, means that is not collection of data of within any range. For example, if we tossing a coin or tossing a die, that coin, then probability of coming head either tail is 1/2, means 0.5. It is a number. Similarly, tossing a coin, then coming 6 is one time, coming 5 is one time. Similarly, coming head is only one face, tail have one face. So this is whole number, this is a number. But for the random variable, we never talk about the number. We talk about a range, means between very small range we talk about where data lie. So this is not a particular number, it is a range. Random variable means it is a range, not a particular number 4, 5, 7. Number lie in discrete, range lie in random variable. Which type? For example, waiting time. For example, if we visit any doctor's clinic, then how much we have to waiting for visiting the doctor, or if we are going for bus stop, how long we have to waiting for next bus or our bus is coming. These types of problem we can discuss in the random continuous variable. And the causing toys or this type of event where the outcome is the fixed, either true or false, either this or that. This type of event we discuss in the discrete variable. So now you better understand what are the discrete and what are the random variable. So today we discuss about the continuous random variable. Continuous random variable means a random variable given range is continuous, not breakable. Then how we find it's all mean, median and the variance and all that things. So today I discuss the about the how we find out the its probability density function and all that thing. So when we talk about the continuous random variable, first we have to find out the PDF. PDF is probability density function. Clear? We write this is small f of x. X is our that variable. Okay, within range. Means what is the random variable? If we have set of data, then if I say we want the probability that I have to waiting less than 10 minutes, more than 10 minutes, then less than 10 minutes means if our range lie between 20 to 30, range lie between 5 to 30 minutes, then what is the probability we have to waiting for less than 10 minutes. Less than 10 minutes means our probabilities lie here. Less than means from here to here. We have to, our area is this probability and we have to find out this time. Clear? So there are, for probability density function, for this continuous random variable, we have two type of random variable. Number one is uniform distribute. Uniformly distribute, uniform random variable. Second is exponential. Exponential. Clear? So uniform means what? That it will be distributed uniformly means its density it at every place its value is not exceed this line. So this is uniform variable. For exponential probability density function, it is goes like this, like a exponential curve. So it will be depend on this area. So we discuss both. For this uniform variable, always probability density function fx is given by a constant c or any constant. At the end we have to find out the value of this. And then for exponential variable, exponential random variables, we have a formula for finding the PDF. That formula is fx is equal to 1 by alpha e to the power minus x by alpha, where alpha is the mean of our given random variable. So this is our PDF for exponential, and this is our PDF for constant variable. Now how we derive this constant variable? See, we all know our probability density function fx area, if it starts lie between this range to this range, then this total area is equal to 1. Always probability density function area is always 1. Either that was exponential or uniform. So this is equal to 1. And there are, if we talk about this is x point, then this one is x plus delta x, means very small deviation delta x. Then within that means there are infinite many points we can plot between this range, correct? So what is the value of from minus infinity to plus infinity? If we integrate this function from here to here, our value of this function comes 1. Clear? Because total area is 1. So value lie between minus infinity to plus infinity, or whatever our range, probability density function value is 1. So if we construct fx, see, if we will have to find out in the given range, we easily find out the value of c. You can further we will discuss in the example. Similarly here in exponential function, we have the range, they give the mean point or mean value of that range, then we can find out the probability, or we can construct the probability density function in terms of exponential random variable. So this is all about the exponential. Now how we find out the probability density function? With two. One is with the help of integral, second with the help of finding the area lie between this. So I think with the integral is more simplest form. Just we integrate very simple single integration with definite limit, we can find out the value of that area. So we discuss about the integration. Some more properties about the probability density function. Number 1, that probability density function is always positive. Fx is always greater than 0 and maximum is 1. It is never negative. Total area is 1, and at any point, I always say that random variable, always we discuss about a range, not a particular point. So probability density function always for random continuous variable on a point, that particular point is 0. Probability density function for particular point is 0. That particular point means f of x is x. At that point it is always 0, but at that particular point. But any other way within the range means 2 to 3 minus 2 to 4, within this range it will lie, it have some value, but at that particular point we can say this is not defined. Clear? And one more thing about property of this probability density function, means we can say if PA x to b, a and b not include, p, a greater than equal, less than equal to x to b, a include in this limit, p, a, x, b is also include in limit, and p, a, x, only b include in this, means value of all these are equal. This either these points are include open interval or close interval, that is not matter, either open or close, both having the same values, either that, because that lie within this range a and b, either a is include or a is not include, there are infinite many points, so value of this when we integrate it will be not change, so that are the same. So now we discuss some problem how to find out the probability density function and how we solve. Clear? So I discuss one example for the probability density function, so we better understand how to find out the PDF for given random continuous variable. If find the PDF where fx is given kx square and 0 within 3 otherwise. It means fx lie between the limit 0 to 3 and all other values going to be 0. So we have to find out first the value of k. First determine k. Second, find probability of x is not greater than 2. Means what is the probability that its waiting time or anything is not greater than 2. Third, find the probability between lie the range 1.5 to 2.5. Clear? So this and 4 is the given that probability x is less than 0.2, given that probability that x is less than h is 0.2. Find value of h correct up to 2 decimal or 3 decimal place. So we go step by step. From first we have to determine the value of this constant k. So value of this constant k is determined by our integral is minus infinity to plus infinity. Means here our lower limit is 0, upper limit is 3, k fx is kx square dx equal to total area lying between this limit is 1. So with the help of this integral we have to derive value of k. So I rub it. Now if we integrate this, k is constant, taking outside, integration of x square is x cube by 3. I put 3 here, x cube 0 to 3 when we apply equal to 1. So when we apply the limit, 3 3s are 9, 3s are 27 equal to 1. So this is 9. So hence our k is equal to 1 by 9. Clear? Now our k is 1 by 9. Means our probability density function fx is x square by 9. This is uniform variable, not exponential. Exponential variable means e to the power some function. If some simple function, then it is uniform random variable. Next, what is the probability density function? X is not greater than 2. Clear? So not greater than 2 means lower limit start with 0 but not exceed 2. Fx is x square by 9 dx. Clear? So 1 by 9 x square, integration is x cube by 3. So x cube by 3 I am writing outside. X cube limit is 0 to 2. 2 times 2 is 2 to the 4 to the 8. So this is 8. Value of this is 8. So what is this? 8 by 27. So what is the value of this? Is 8 by 27. So probability that does not exist greater less than 2 is 8 by 27. Now how we find 1.2? Same 1.2 to 2.5, our probability density function x square by 9 dx. When we integrate it, we can find out the value of this. Its value is 0.454. You just calculate, so it's very easy. 0.454. Now the last question, given that probability that x is less than h, this x means our probability density function is less than h. If this x is less than h is 0.2 means our probability density function, if this x is less than h is 0.2. So how we find out? We find out, see, our probability density function from 0 to h. Less than h means 0 to h. Our function is x square by 9 dx. Its value is, area value of this is 0.2. So you just integrate it, you will get the value of h. When we integrate, this value of h is 1.75. 1.75. Clear? How to find out all these values, whatever they ask, all these properties. Next, I will discuss for the random continuous variable, how to find out the median of continuous variables. So this is PDF. Next step is median. Mean we can also find out. First we find out the median. Mean, mode and median you already studied. Median means what? Yes, median means the mid value of given data is defined, which is divided. If we have 1, 2, 3, 4, 7, 8, 9, then this and this. What is the median? Median is the 4, mid value. If we have even numbers, then what is the median? This plus this divided by 2. That is the median. Clear? So median means mid value. So we can say in random continuous variable, this median divide whole area. If this is from here to here, then divide whole area in 50% here and 50 in equal to halves. Like in normal distribution, we can say that bell-shaped curve divide with its mu. Its mean like it's 50% and this is also 50%. So in random continuous variable, we can say median is also divided into two halves. Either that was exponential or that is uniform curve. So how we find out, if we can, they talk about the how we find out the median. Median means if we have to find out x is not less than equal to median, or that x is this. So for this and this both if less than, so 0 to m fx dx, this is our probability density. But this is equal to how much? Half of this. This half portion is just, we can write this probability density function is 1 by 2. With the help of this, we can derive the m, our median also. Same, this is also m to maximum point, m to infinity, fx dx is equal to 1 by 2, whatever the upper limit for either this type or this type. We can derive the median very easily. Next we have to discuss about the variance and mean of random variable. Next is the mean. What is the formula for mean of random variable? Mean is given by, we can write mu. Mu is given by minus infinite to plus infinite x of fx dx. If x is not there, this is our PDF. If x is there, this is formula for mean. And the one more thing, variance. Variance is our sigma square, because sigma is standard deviation, sigma square is variance. So sigma square variance of x. This mean is also known as Ex, is expectation value. So either we can say expectation value or we can say mean. Next is the variance. So variance is equal to minus infinite to plus infinite x square fx dx minus of our mean square, or we can say expectation value. So this is the formula for our variance, this is for our mean. So we can, whatever the given data, we can easily find out the median, mean, variance or any probability lie within that range. So you can easily solve this. Now we go for one formula, one example, how we have to define it. So you better understand. Just one very simple example. If we can say a continuous random variable u is uniformly distributed between the 0.5 to 2 point limit shown, first is find f of u. F of u means our probability density function of that. Second, state mean of u. Third is calculate the variance. Sigma square. So first is this fu. For first working, we know our lower limit to upper limit fx. If they say this is uniform, so our function is only any constant. If I say k, then k of dx at fx, fu is k of du, our variable is u, is total area under this limit is 1. So k, with the help of this we can find out the value of k. So k u is 2.5 to 0.5 is equal to 1. So k upper limit 2.5 minus this is 2 equal to 1. Hence k is equal to 1 by 2. It means our fu is 1 by 2. Clear? This is our first step. Second, we have to find out the mean. So what is the mean? Mean is fx, at the place of x our variable is u into fu. Fu is 1 by 2 du. So 1 by 2 outside, integration of u is u square by 2. So 1 to outside, u square 0.5 to 2.5. You just substitute the limits, you will get mean equal to 3 by 2. Value of this is equal to 3 by 2. Clear? Third is the variance. Variance is also same. Variance is what? u square 1 fu du minus of mean square is 3/2 square. So we have to find out this value minus this value. In this case our variance is 0.333, or we can say 10/9. Clear? Similarly, if we talk about the median, if they find out the value of median. Median is what? Median means midpoint of random continuous variable. So for the median, what is our 0.5 to n. Fu is what? 1/2 du. Value of this probability density function is half. With the help of this integral we can find out half. If we can cancel out, so this is du is u, 0.5 to 5 is equal to 1. So m minus 0.5 is equal to 1. So m is 0.5. Clear? So median value of this is also 0.5 because it is a constant function. Clear? So with the help of this formula and with the help of my lecture, you can easily understand what are the random continuous variable and how we can find out the all different variables and probability density function for the given data. Thank you very much.